So I will start with a first production, just to show you the flavor of where Demoscene started and how did it originate. So just to ask a question to all of the people to know to whom I'm speaking to, is there anyone on the audience who knows what Demoscene is? Please raise a hand. Okay, very good. That's not bad, but there are also people who don't know. And for those people, I hope to keep you, all of you, for 1 hour here. So I will start with a short story. We are at the event connected to games. And Demoscene is in some way connected to the games as well, not only because of the graphics and animation and music, but also because of the origin of it. So in the past, when people started play games on personal computers, there was a need to exchange games between people. And they sent, they of course cracked, they were cracking games, and it was illegal, which is not connected to Demoscene that much. But people wanted to inform each other about the person who cracked the game. And of course it started with just a notice at the very beginning, in the intro to the game, that hey, hello, I just cracked this game, you can write to me to get more cracks and so on. And there was another person who wrote it with different font. There was another person who added some colorful bar. There was another person who said, hey, come on, that looks nice, I will do some more colorful thing. I will do some more animation. I will do some more like a rotating cube. I will do nice music and so on. And then there were people who said, come on, is the game really important here? Let's skip it and do the intro. And okay, I'm the better one, so I'm the better, so let's meet all together. And the people started to meet at events like MAGFest, but they started to meet to show off those intros. And they wanted to compete to each other, to say which one is better and so on. And that's how the Demoscene could be described in like 1 minute. And I hope you already your imagination can now develop this thing into something more precise. I will now go through all of this in my talk. So I will show you one, of course, example that you probably know. Okay. This is an intro from 1987 by the group Farlight. So it's already at this stage where people started to use graphics and animation. Okay, that's it. You know it. You can go to Computer Museum to see many examples like this at some of the games, but now I will show you how it developed. I'm sorry, can anyone help me with this table? Okay, now let's go. So it of course developed in a way that people used more sophisticated graphics and animation. There are only a few examples. If you write in YouTube or anywhere, YouTube now is very popular, okay, amongst sceners as well. So people put many of Demoscene productions on YouTube, and I will also use it because it's convenient. Keep in mind that what I show you is all real time. So that productions are generated at the time they are showed. So this is like a game, but made like an animation, but produced in a real time by computer code. And all these are examples. So you already have this three-dimensional thing on the right top side. So you have the three-dimensional object there, and people started to develop it. And they started to meet. And the meetings like this started in a small scale. The story is similar like at MAGFest, where people started in less than here, what we see today. So that was a party in 90s. It was, probably that was assembly, but I'm not sure. So it looks like 90s. People were bringing these monitors, which were big, and they really carried it through kilometers. So I remember in Poland, we were carrying our huge computers were not huge, we were Amiga fans, so we had small computers, but the monitors were large, and we had to have them on the demo party. So every time time the people meet, it was like 300 kilometers in a train with these monitors. So yeah, people were crazy to do that. But it was very fun, and the people were, you know, from the picture, and they enjoyed this. And the party, the purpose of the party was to meet, to watch the demos of other people, but not only. It was also about the competition and about showing off your work. So I always, when I give a talk about Demoscene, what is the most important message for me is to convey that, remember that what is very, very important for me as a scener is that I work for half a year on something, or some people work for years. And there is a place where you can go, bring this thing you were working on, and show to other people who were doing the same for the last few months, working on their own productions. It's really very enjoyable that you are like showing among the community of people who are doing the same. And now how this whole thing's developed. So with development of personal computers, the Demoscene developed as well. But of course there were there are retro machines that are available today, but they are from the past, and Demoscene is still producing, Demoscene people are still producing productions for these machines. And one example is Commodore 64, where with a new techniques of rendering graphics and rendering animation are created, especially to create some effects. And one of the examples is Demo Lunatico from LFT group, LFT. This is actually a person. I will now play it for you. I will not play the entire demo, so I recommend you to watch it as a whole. I will just play like 2 minutes of it, just to show you how it developed in years, and that people are still doing something for these machines. And this is from, which year was it? 2016, yeah. Less than 2 years old. And this demo didn't win. That was a second place at the party. One person created it, yes.
I would like to say why this demo is here, because tomorrow you're going to experience coding shaders, and this is like a Commodore pitch on shaders. It processes images with some ways to process image. I mean, you code something that processes graphics, and this demo introduced two new graphic modes in Commodore that had never been seen before. So in 2016, after 25 years of Commodore being existing in the world, somebody invented two new graphic modes. Now you can see that that's real time. So, and in high res, which is like the designers of Commodore never thought of these modes. It's double resolution of what you can see in every Commodore game, and it processes this image in real time. So it's not an animation.
Okay, I will now proceed. So that was Commodore 64, and okay, it was not a demo to show off the Commodore possibilities in Demoscene, because there are demos with 3D graphics as well, so even better, but this is technically really advanced. But then with development of computers, the demos developed as well, and one of the good examples is Amiga, which was also very nicely adopted by Demoscene. So many people joined Demoscene also because of the computer itself. It was so Amiga is a computer which has a special kind of which had a special kind of construction. It is constructed from with specialized microprocessors. So there is a copper, blitter, and things like that. Not only CPU. And these special processors were used by Demoscene to produce effects. So for example, Blitter may have been used for filling vector graphics. Copper may have been used to produce some color effects and with colors. And CPU was used to calculate rotations and things like this. And that was how the demos on Amiga 500 were coded and produced. So now I will play the Amiga Demo from Poland. This is technological dev, and I play it not only because it's nice demo, but also that was the first demo that I saw on a Polish television in 2095, I guess, and that was something that attracted me to the demo scene, because, yeah, not only because of the technical things. There you have the vector graphics with lines. It's not real time. We don't have Amiga here connected to everything.
So as Marku said, Amiga had many custom chips to process some tasks, like music, graphics, rendering, color. So it's it's comparable to most consoles. Consoles have custom chips to do some stuff that is needed. And Amiga was a computer, well, is a computer, but it had a lot of custom chips to do things that are needed to produce audio-visual effects. And that was really special at the time when Amiga was introduced. And, well, still is. The computer is quite special. And this demo was one of the first that had some complex design. You can see there is a timer. It counts down to the end of the demo. There is like music goes with what you see on screen, and that was one of the first to make it synchronized. You need to code it in. It's not like timeline, it's not like video editing. You have to do it in code to make it perfect. And yeah, it was quite famous because of that. Like, let's see. Yeah, like that. So I think it was probably the first Polish demo that was famous outside of Poland. And none of the guys that made those that demo were older than 20 years when they did it.
Doesn't matter that older people do then demos, they still do. 'This is a typical part for the Demoscene production. There are greetings, so one group is giving some greets to another, and people are like very friendship at Demoscene, and that's an example. Yeah, so.
It's 24 years old, and some of these people, well, some of these groups still exist.
Okay, I'll now skip to another one. So that was Amiga 500, yeah, with specialized microprocessors. And now, because of the MAGFest and all this console stuff, we also prepared a demo for you. Not we who made the demo, but we have a demo to show part of it for a console, and this is for Sega Mega Drive Titan. And this demo shows that also people interested more in not only in personal computers but also in consoles are doing demos. And yeah, so enjoy.
Less than 1 year old.
Yeah, so as I mentioned, it's a similar machine to Amiga 500, yeah? So with a processor and yeah, Motorola 68K. That's a good question. Thank you.
By the way, Revision is the biggest demo party in the world. It happens in Germany every Easter. So if you really want to experience Demoscene and you want to go to Europe, that's the place you have to go.
Another style of demo because there are not much about your effects. It's more about now getting some graphics. Okay. That's what I mean. There is some story and narrative stuff.
To add, I was on the same YouTube feature as the coder of this demo. It's Overdrive 2, made Overdrive 1 and 2, and somebody asked him if he's going to make Overdrive 3 or something else, and he said no, because we want some competition on Mega Drive. So if anybody makes something at least as good, we're going to continue, and if not, well, he said, maybe SNES next time or something like that. So they are looking for competition. Consider it, people.
Okay. So that was Sega Mega Drive. Now the development is of course towards. I mean, part of the Demoscene is very much oriented into new, faster, bigger. I wouldn't call it better, but in some way it's more developed graphics effects. And one of the examples is development of Amiga machines, which developed into more sophisticated graphics effects on AGA machines. So for instance, Amiga 1200. And this is Amiga, which is very well known at Demoscene. It developed Demoscene very much, the development of this computer. And I will now show you the demo from very known group at the Demoscene is the Black Lotus, the demo Rift. It's on a computer which has already more colors and more possibilities. And one of the techniques developed for this kind of productions is chunky to planar. It's another way of producing graphics on Amiga machines. And yeah, so after I mention this, I can play. And one of the things is that these computers also are equipped with turbo cards, so they are faster than originally created with more powerful processors. And this is the Black Lotus. Argasek wants to say.
So just a quick announcement. Tomorrow, if everything works well, in the Computer Museum, there will be such Amiga as the one used to create this demo. So you could go there and watch this production amongst others and experience it the way how they were supposed to be created. Thank you.
From executable.
Yeah, I think it's worth mentioning that Amiga doesn't have any 3D capabilities. Everything you see here is rendered by CPU, so it's quite difficult to do it.
Okay, so because I'm also a coder, so a person who writes a software like this for Demoscene, I can say even more that most of the things that you see here are written by the people who are doing these productions. So they are not doing like using third-party libraries for rendering here, because this is what gives a value there also. Okay, so this was a demo for Amiga. Okay, let's see this effect. This is the last one we will watch, and then later we can. Okay, these were the greetings for the groups, yes, which I mentioned before. Okay, now we are almost done with the presentation of Demoscene. I want to mention again something very important, that Demoscene is not only about production, it's about people, about community. And this community is large. So I joined Demoscene like 15 years or 20 years ago. okay, and I live with it, okay? It's something that is a part of my life, and the part of my life are these parties. These parties are special kind of events at which people are bringing some productions to show other people, and also there are people who organize party, who are like keeping the connections between people together. Maybe not that much this time, it was more before, but there are sometimes many people, like on the revision mentioned by Faye. And this is a party from 2006, it's Breakpoint. It's a party that was before revision in the biggest party in Germany. Okay, it was closed and then the revision was created. This is 2004 assembly in Finland. It is not very Demoscene party. Assembly is a computer game festival, may I call it like this, at which the part of it is the Demoscene event, and it looked like this in 2004. Now, this is a picture from Breakpoint, from Revision, and I just show it to give you a flavor how it looks like when people are watching these productions. This is the most important. People are very concentrated. These are like they gather all together in front of a huge big screen with a nice audio system, and this is like the event for all these creators. And now I will show you something which all of you give a flavor of what the spirit of Demoscene is. And this is my favorite moment of this talk, because I will show you a screening from the actual demo. And this is not only about screening from the screen from the party, it's also about the reaction of people who are watching it. So now try to put your, I don't know if I say it properly, but your legs into the shoes of these people who created this demo, who are actually watching it all together at this demo party. And every time I watch it on YouTube, I like it because I was watching this demo from my home, from the streaming as well. So I enjoyed it as it is, and this demo is the first one in the Poet list on the internet as the top known PC demo. And to be honest, maybe it's not the most advanced now, but there is something special about it. This demo was presented in a category of the demo, like a largest production at Demoscene, but it is limited in size by the creators. So it's like 250 kilobytes of executable file, and that's all. There is no music, no 3D graphics, no textures, nothing. There is one single executable file, which produces all that you will see now. So now enjoy.
So he was watching it at home. I was there in the first row. Some of the shouts are sorry. That's Polish people singing, unfortunately. It's not loading, it's 250 kilobytes. It's generating sound, textures, everything. So it's not, loading.
Anyone knows what city is that? What is the city that inspired Outdoors? So it was 23rd demo showed in this whole Demoscene on this night, and yeah, it was end of the compo. So yeah, you watched all the demo. Congratulations. So that was Farbroush group, and it was actually hard to finish at some point. So if I wanted to add something.
I wanted to add that it's 10 years old now, so if your PC is 5 years old, 6 years old, it perfectly runs it. So download it, try it for yourself. 256 kilobytes is not a long time to wait, and then you just run it and you experience it.
Okay, now let's continue, and this is the end of the Demoscene introduction. I'm very sorry not saying more about it. There is a lot of stories, a lot of demos I would like to show and tell you about. But now we move into this part about the writing software for Demoscene. How do we do that? What is the new at Demoscene? And we will, of course, narrow our presentation so that you can actually catch up some technical stuff as well. So tomorrow will be more technical presentation about shaders, and now how did the shaders come at the Demoscene. So the Demoscene engine is actually something like a game engine for the graphics. So usually it's 3D, it's about texturing, it's about the 3D graphics with 3D objects, with lighting, all this clipping, shadows, transparency, depth of field, and so on. And one of the dream at the Demoscene by the coders or by actually creators is to have a fast ray tracing. Because fast ray tracing is actually something that is solving a lot of problems and a lot of issues that are connected with rasterized engines. And fast ray tracing was not available until GPU era came. And so GPU computer graphics cards developed recently for last like 5 or 6 years are giving us a lot of possibilities, I mean for us, for the programmers at Demoscene. And now I will show you what happened at the Demoscene with the effects. So 3D graphics card has a special unit processor that is capable of running programs written in shader languages. Shader language is just a special kind of language in which you write a program for the graphics card, and you can describe properties of vertices and of pixels of your display. So for instance, if you have a 3D engine, you load a model, 3-dimensional model, and you have a graphics pipeline. And in this graphics pipeline, you may use shader language to describe what happens to your vertex or to your pixel at the screen. I want to put it in simple words because I imagine there are people who are not programmers even. But it's really, in the principles, it's really very simple. So you have 3-dimensional object, like my laptop here, described by some vertices that says there is a vertex, there is a vertex, there is a vertex, and there is a vertex. And you can run a program that says that all the vertices will rotate by some angle. And this single program runs on each vertex of my object. And this is principle of shader and shader language and writing shaders, and there is nothing more. All the other stuff is doing configuration, installing libraries, and so on and so on. But this is principle. Now, this is the vertex shader. The other thing is a pixel shader. Means that if your picture is already rendered on the screen, or let's say in some kind of buffer, because there might be pixel is somewhere in the middle of the graphics pipeline, then there is a special program that runs at each individual pixel on the screen, so that you could say, for instance, that each pixel will have like a color divided by 2, so it will be more dark. And that's it. Okay, for the moment, let's understand it in this way. So we have shaders, and what GPU gives us, so the graphics card, and what gives to Demoscene, to the effects, to games, is that there is a special processor that can immediately, just in a matters of milliseconds, run millions of these programs, which are the same for each individual vertex or for each individual pixel. And this is what gives this amount of power that is possible for us to turn into algorithm to render, for instance, fast ray tracing, okay? And this is what happened at the Demoscene, that adopted the technique for rendering with shaders. And there is a famous talk from 2008 by a person who is actually very important at Demoscene and at this for this community and for this technique is IQ from RGBA group. So IQ is a coder who created many Demoscene productions using this technique, and also wrote the shadertoy tool that we will be using for this workshop. So he presented a talk about rendering words with two triangles. What does it mean? So there is a special way to produce a graphics in which you can use a pixel shader for each individual pixel on the screen. So basically you render a three-dimensional object in 2 dimensions, which is created from 2 triangles. It might be 1 quad, it's no problem, but we have 2 triangles. And now you run a pixel shader for each individual pixel of this screen. And you produce picture like on the right-hand side. How you can do that? So the idea is that for each pixel you know the position, and you can use some algorithm to create this graphics. And now to do that, I'm sorry, I have to. Okay, now it will not. 20 minutes is enough for this. So okay, now I will show you how is it created with things like pixel shader. So we have 3 basic classes of effects with this technique. So again, the message now is that we have a single program that runs for each individual pixel on the screen. So the basic shader would be that output color is simply black. Yeah, that will be the simplest one. But the more advanced would be that the pixel color on the screen is connected with pixel position. So for instance, on the left-hand side will be black, on the right-hand side will be white, okay? You can do the gradient just simply by taking the position of the pixel. Because what is important is that this program, so this, like a part of this piece of code, knows where the pixel is on the screen. Okay, so now let's go through these 3, and I don't expect at all that all the people will understand immediately what does it mean, what I will show. The message is we have 3 classes, and if you go out from there today with the knowledge that there is something like shaders, and this guy was telling something about 3 techniques, and there are 3 different, that's enough. Then you come tomorrow, if you are still interested, and you will get some really like a basic introduction into principles of these 3 techniques. Okay? Now, distance function. Distance function is something connected to what I said about the gradient. You know where the pixel is on the screen. So you could, for instance, calculate the distance from some specific points in the screen. If you do that, then you can apply functions like a step function or smooth step function, which says how color changes with the distance from some other mathematical formula. And if you use this mathematical formula, you can get effects like this. This is a simple shader we will be talking about tomorrow. This will be first technique that we will program something all together in very simple way. It's a it's an effect, yeah? On the left-hand side, you have this working real-time on this machine, on this laptop. On the right-hand side, you have a code. And this is something we will be working with. This is a shadertoy, is a web application in which you can write shaders simply by writing this in the web page, okay? So it's very, very simple you don't have to configure it, you just go to the web page and you start programming. Yeah, we will start from scratch tomorrow. And effects like this you can obtain after this workshop. I just, Okay, so now that was distance function. This is the first class. The second is plane deformation. It looks more complicated, but it is not really. It's connected to retro Demoscene, I mean to retro effects, because that was a technique used for Amiga and productions and not only. This is a deformation of texture. If you put a texture on a screen just by doing like position in the screen is the same like position in the texture, and you use some mapping function, so you simply take your position in the texture and you change it somehow, but continuously, so that you use some nice function. So if you know the function to use, you can write like 10 lines of code and produce effect like this. This is just a three-dimensional tunnel. Okay, you will see how short is the code. If this transfer the data from shadertoy already. Yeah, okay, we have it. Or we don't. Okay, we have. So this is the three-dimensional tunnel, three-dimensional-like, I would say. This is not three-dimensional, it's just a mapping, and with a nice function. And of course you can like click it and, oh, there is no click function, but yeah, the code is very short. So all you see on the right-hand side is a code that produced the effect on the left-hand side. The rest is loading textures, and that's all, yeah? So this is the thing. Okay, I will not go into details how to do that. This will be discussed tomorrow. Okay, and ray merging. This is the third technique, and this was something that was catched by the Demoscene people. So they used this fast ray tracing algorithm. Basically, this is an algorithm that helps to provide a distance from the point in 3 dimensions to the scene objects. And it does it really very quickly, especially is suited for GPU. So people started using it, and this is amazing what this can do with 3 dimensions. So for instance, I just run something which doesn't show everything there, just show some basic primitives, just to give you a flavor, what is this about. Okay, this laptop is not the fastest one, of course, and this cost more than the previous effects, but this is basically 3-dimensional scene with soft shadows, with, there is some sort of texture on the ground, maybe not very sophisticated, and you have some basic primitives from which you can build some scene, of course. This is only, so this is an example of a code made for other people to inspire and use, because you have all these distance functions on the right-hand side written in a way that someone else can also use, okay? And this will also be introduced tomorrow. Be aware this is not easy and simple technique, but I decided to give you it so that you, even if not get it at the MAGFest for this 1-hour lecture, you will know the basics of this technique as well. So it will be covered tomorrow. Okay, so that was ray merging, okay? And again by IQ. And now the shadertoy. Shadertoy is a tool which gives us possibility to make workshop here. It's done by Inigo Quiles together with Polyermias from the created company BeautyPie, but it's not about the commercializing shadertoy. It's free for Demoscene and so on. They are actually working in other places. It's WebG, so they do it like in the nights, yes? This is like a hobby project more. It's a WebGL application. It's a database for shaders. So basically you have like 19,000 of shaders already. They succeeded in creating a community of people who are writing shaders. It's not only about Demoscene. There is another community. This is what they actually say now, that it happened that people gathered together and do shaders only for shaders, because one gets something from another shader, make another one, they like inspire. And this is what they say. Take the code, do something with it, publish it. Just do it so that it develops all the community. And it's really very, very nice for learning. Many techniques, not only those that I showed you. And yeah, so you can basically do nice stuff here, not only simple effects that I will show here at this workshop. I limit it somehow. This is not about everything there. Be aware, because there is also a technique that will be not covered at this workshop. Is a multipass shader technique available in shadertoy, in which you can even write a game. So the one shader produces data for another one. And people do that, so it's possible. This was version 04. So it's like MAGFest in 10 years ago, yeah. And then, of course, that was like a toy for IQ to write shaders. And now this is the shader toy today, and it doesn't show everything here. It looks more like YouTube. You have these shaders. You can choose from them and play and fork and create account and like it. Yeah, there is a like button even. Okay. Yeah, and 3-to-1 shaders. We don't have much time. The presentation will be available for you, and I will just go quickly through some examples of shaders created by other people, so that you see what we are able to achieve. So one is a shader by IQ. I didn't choose more. He is really a very productive person. So this is a three-dimensional ray merging done in one single shader. So on the right-hand side, you have a code that produces this picture on the left-hand side. So you have some bloom effects and textures and environment mappings and three-dimensional objects and so on. So yeah, this is example of ray merging. You can also write sound, so people who produce music may be interested in creating music in a shader. I'm sorry, I cannot play it. This is not the... So there will be another one with sound. Sorry, I was testing this on another browser. So now this is kinetic, inverse kinematics, something that you may know from games. So like three-dimensional object in which you have some legs and connections and things like this. So it's still a single program. There is no other thing. Okay. It's again ray merging. Now something else. It's I promised something about games. So there is an example. It runs or not, because this one was. Okay, this is a flavor of running something real-time at the real machine, yeah? I could have some YouTube videos for you, which I didn't do, so that we can play it. Okay, let me go further for the intro. Sometimes happens that you have installed the WebGL in a version that is not appropriate for a given shader. So this is an old-style retro intro written in a shader on GPU machine. So you have GLSL version of some, yeah? And the music is created in a shader as well. So you have this shader creating the music for the buffer of the music card. Yeah, it's a kind of special technique. So that was an intro. The same person made an image compression in a shader, so that you could also have some graphics here. So now we will see how it decompresses. Yeah, so this is the image, which was compressed and decompressed in a shader. And the music is generated as well. Okay, now I'll just go into the last example, which is quite of unique. It's a software renderer written in a shader. So it's a software rendering. It's for the coders. It's really special because it's a rasterizer written on GPU in a shader. It's kind of like quantum mechanics, I would call it, okay? It's so just texturing, okay? But this is from the perspective of a coding, it's really special. What do you see here? Because, yeah, so enjoy. So, because it's written on a graphics card, but it's written in such a way that algorithm is creating the texture, three-dimensional textured object, which is just kind of strange. It was in the past that CPU was created, that people were writing their own software renderers, but here is on GPU. Okay, let me just finish this. This is an example that not only shadertoy exists, there are other web pages at which you can also write shaders, so be aware. There are shader-based demos. We will not show them. You will get the presentation so that you can easily watch them on YouTube or from the executable. So these are very nice productions written with shaders. And that's almost all. I invite all of you for tomorrow's lecture, which will be in the same place at 12 p.m., We have 3 minutes, and the last one is this talk was supported by the Polish Cultural Institute in New York and Polish Embassy, who actually covered the cost of my presence here. So thank you very much, and I hope to see most of you tomorrow. There will be also some screenings, so we will show some demos. Don't be afraid that I will just code and do something. No, but we will also do coding, and you are all invited to bring your laptop to sit down and just type some little things in a shadertoy so that you can start. And tomorrow will be also announced a workshop. So we will have 1 hour here, and then people interested in writing their own shaders will move to Forge, Baltimore 1-4 room, in which you will be able to sit for 2 hours and write your own shader with my assistance. So I will help you to start off, and then there will be competition. So you could write your own shader, send to us, and we will evaluate it, and you will be watching it on Sunday morning, 10:30 p.m., here in the same AM, in the same room, and there will be a prize. So you are all welcome to feel a spirit of Demoscene, and I hope to see most of you tomorrow and day after. Thank you very much.